Thanks, everybody. My talk's going to be a little bit different than Sam's. Great job, by the way. But my talk is really about drawing funny shapes. Like Chabot said, this year we changed some things in the backcountry side of our forecasting program. We do highway forecasting as well as backcountry, and so I'm not going to talk about the highway side, which is sort of started before this and is then sort of leaping ahead right now. But this is really just the backcountry part. There's a lot of people that have contributed to this work, really too many to name, but here's some faces and some names of some of the major contributors. So really big group effort from the staff at the CAIC. A lot of this work is done through a partnership with Avalanche Canada, and then we have the Friends of the CAIC that pay for a lot of stuff, so couldn't do it without them. So the two main things that we changed this year in the backcountry program are that we changed the spatial structure of how we're issuing forecasts. We've been using kind of a 10-zone paradigm, and we've moved to this dynamic zone forecasting model. And then the other change that we made was we started issuing forecasts in the afternoon. So we used to issue forecasts for Wednesday on Wednesday morning, Wednesday and Thursday from Wednesday morning. Now we're issuing forecasts for Wednesday and Thursday on Tuesday afternoon. So Chabot and I were talking about this, and he was like, tell us how it's going. So that's what I'm going to do. So just a little bit of history. The Colorado Avalanche Information Center has been issuing public safety products for a long time, since the early 70s. And there's been a progression in terms of how those products have been issued. They started out as statewide discussions, so covering all of the mountains of Colorado. In the late 70s, they moved to these 3 regional products. And that really lasted until the early 2000s, when we moved to this 10-zone paradigm, which we've been using up until this last year. So just looking at some of the problems we were trying to solve, I'm just going to look at kind of 2 of our forecast zones. This is the Vail Summit forecast zone. And it's about 50 miles on a side, so about 1,600 square miles of terrain. It covers 4 major mountain passes. And if you just look at the annual snowfall for some of the areas in there, it's relatively uniform. Kremling is way below the mountains, but not too bad looking across that. Like, you could sort of see how we might see similar avalanche conditions across that zone. This is the northern San Juan zone that we used to use, and so it's a little bit different here. Kind of oblong, but we're dealing with a much bigger area. This is about 4,400 square miles of terrain. And if we look at the annual snowfall across this area, it's really not the same. There's really no better way to put it, I think. So as we were trying to describe avalanche conditions in these zones, we would come across kind of the same problem. On one side, it's considerable. On the other side, it's moderate. Do we call it moderate and say it's more dangerous over here? Or do we say it's considerable and say it's not as dangerous over there? And so because of this framework, which was very useful for many years, we were constantly kind of fighting against ourselves in terms of how we were describing things to the public. We would know more about what was happening in these areas, but because we had to get everything into this box, we had to make decisions that were based on the communication and not the conditions, not the avalanche conditions. So we felt a little bit like we were herding cats. We knew that these cats were running around in the terrain. We knew a lot about what they were doing, their size and shape and color. And then every morning we try to put them into these boxes and describe which cat we had in which box. And so we were like, well, there's got to be a better way. Let's just let the cats go where they want to go. They can settle down, and we'll just describe them where they're laying. So the question was really, how do we do that? So we work very closely with the National Weather Service, and so there was an obvious group for us to talk to. And this is the forecast zone schema that the Weather Service used up until kind of the early, maybe mid-90s in Colorado. So you can see there's about 100 forecast zones, and they drew all these funny shapes. Remember, I was going to talk about funny shapes. And so they're describing the weather in each one of those funny shapes throughout their 24-hour forecast cycle. And then in the mid-90s, they switched to a gridded forecast. So they took this gridded shape, just a whole bunch of squares, essentially, and set it over the state and really the whole country. And then they describe what's happening in each one of those little boxes. And they have a lot more capabilities in terms of understanding the weather and being able to simulate the weather across the country. But we were like, hey, this is really something that we could do this sort of similar to this. This grid is not what they use. They're using a 2.5 kilometer grid over the Western United States. So that's just there for effect. So we're like, okay, so here's one of the products that they do. So this is 6-hour precipitation in the Leadville, Summit County area. And you can see that they can describe pretty well what's happening. And they don't have to say like, well, some places it's going to snow 2 inches, and some places it's going to say 6. So we'll just say 4 everywhere. They can say, going to be 8 inches over here, going to be 3 inches over here. And so that's sort of what we were going for. So we sat down and broke up Colorado into 103 different polygons with the idea that we would take these shapes, this is what we were going to use as forecasters to describe the avalanche conditions, and group them together into common areas. And so maybe we would end up with sort of the same 10 zone or 10 forecasts in a particular day. But this would allow us to sort of say, well, this area really is closer to this place today, or it's close to the other place today, and kind of move those around. And so that's what we're trying to do. And yeah. So this is sort of our process at this point. The forecasters sit down every day with this map, and they say, okay, this area is kind of the same, so we're going to group these polygons together into one forecast zone and write about it. And then they go through and do this really through the whole state.
So there's a few left over.
We're going to talk about that. Yeah, so you can have leftovers. It's okay. It's not restaurant rules here, Chabot. And so then we take that map and say we're just going to focus in on this one area, group these polygons together, and then from there we can say, okay, what are the avalanche problems? What do we want to say about the avalanche conditions in this area? And we can attach a forecast to that area. Then we do that for the whole state. We create this map of these forecast zones that are made up of these base elements. In this case, these 100 polygons. And from there, we produce our forecasts and give that to the public. So then the public can really focus on where they're going. They find their forecasts by searching on a place name or clicking on a map, putting a point on the map, and then we give them the best forecast that we can for that area. And we show them the scale of that forecast as their entry point into the set of products. So that's what we're doing. How's it going? Is a whole nother question. So this is how things looked kind of through the beginning of February. Couple bad days. So you can see things are moving around a little bit. Because it was a new tool, some of the movement, especially early on, was because of people, not because of snow. But we've been working more on how to do that, and so now things are moving for the most part because of the snow. And you can see that we are having more detailed forecasts. We have more forecast products than we used to, but not a huge amount more. It's really fairly similar in a lot of ways. So here's a couple of examples of I guess successes or things that the system allowed us to do that we couldn't do in the past. So this particular day in the Swatch zone, this is the place that Ian used to forecast for. And so these three areas here, the yellow, the red, and the green, those were all in the same forecast zone in the previous schema. So on this particular day, We saw that there was going to be a lot more precipitation falling on Monarch Pass. There's a state highway that runs over that pass. So it's a common backcountry access point. There's a ski area up there. And we could really see the gradient of precipitation, and the avalanche danger was being driven by snowfall in this particular day. So we were able to put out an avalanche warning for a very small area and still tell people that nearby the danger was low. It's just that simple. So this is something that in the past we could recognize, but we didn't really have a way of telling people about it. And in this particular day, we were able to. Another example is some areas where we don't commonly see snowfall or really avalanche hazard very much, but occasionally we do. These are the leftovers. So this year has been, like a lot of places in the West, we've had some pretty complicated weather patterns and heavy snowfall. And so we identified these two areas, the Book Cliffs around Douglas Pass and the Uncompahgre Plateau, that are typically not in our forecast area at all. We don't issue forecasts for them, even though our responsibility is the state of Colorado. So when we saw this potential hazard, we wanted to warn people about it. We were able to light these up for a few days, and then once we felt like the hazard was subsiding, go back to kind of our regularly scheduled program. So you can see the green circle, green dot on the map is where this weather station is, and the green oval is the progression of SWE in that area. And so that was the time period that we decided to tell people about. Okay, so what about forecasting in the afternoon? So why did we make this change? I think there's a lot of people in here who teach avalanche classes. I saw a lot of people stand up when Chabot was asking about that. And one of the main things that we teach people about these days is to plan ahead, figure out where you're going to go. Is this the right day to ski that couloir, climb that peak, high mark that slope? Most of the people in Colorado are traveling to recreate, and we wanted to give them more time to plan. So rather than waiting till 7 o'clock in the morning to figure out what the hazard for the day is, we're now trying to tell them at 4:30 in the afternoon the previous day, and still giving them 2 days of planning. So we essentially extended our forecast period by about 12 hours. It also was beneficial for us. We need more time to deal with the dynamic forecast zones. We have a group of forecasters every day that's sitting down and meeting about how to draw that map. And that process takes some time. And really, we wanted them to be relaxed. Before we were writing forecasts, we had one point, I think actually it's maybe before Ian was working for us, where we had mapped out we had to write forecasts in 12 minutes to cover every zone. And so now we have about 2.5 hours for the forecasters to sit down, look at the weather, look at the observations that they've had, call some operations, figure out what's going on, sit down, draw their map, decide how the products are going to look, write the products, issue them. So it's a much more relaxed process. And this was not really a new idea, although it's new to Colorado and certainly got some people excited. It is something that we used to do up until about 2007, and it's something that's fairly standard in some of the different parts of the world. So it's not really our fault.
And you get to sleep, and you get to sleep in. You didn't mention that being...
We'll get to that. Unfortunately, that was not part of it. So on the left there, we have our operational schedule. And so what we did to do this is we have 3 shifts for the backcountry forecasters a day. First shift, 4 a.m., still up. And so they're coming in, they're looking at what was done the day before, they're making any corrections that need to be made. We do weather forecasts twice a day, so they do that forecast, they do social media, then they hand off to a day shift. We have a senior forecaster that covers the whole day. They come in and kind of continue that process, and then the rest of the forecasting staff, both highway and backcountry, come in midday for a forecaster meeting where we kind of figure out what's happening across the state and what we're going to do about it. And then I put up just sort of some of the statistics that I found interesting about what we were doing. So one of the questions was, how much are you going to be wrong? We do have essentially 24-hour coverage, so we update forecasts whenever we feel like we're wrong. And we're doing it a little bit more than some of the partner groups that we work with. Some of that has been, again, just sort of the learning curve. There's sometimes that people have actually lowered the danger when they come in the morning because they feel like that's providing a more accurate picture. And so we've been trying to work a little bit on like, how big of a change do we want to make to actually issue a new forecast? If we're just going to say that southeast aspects below tree line now have a persistent slab, maybe we can wait till the afternoon to do that. We don't have to do that in the morning. And we do a fair amount of verification of our products. We have not been able to do that in the middle of the winter, so we'll be looking at that this summer in terms of what is our accuracy and how big of an impact has this had. So what's next? It's got to be something else. So just a little bit of look in the future. A lot of what we're trying to do now is really figure out how this map works. And so we're trying to build more capabilities and tools for the forecasters to help them with this distribution. So they don't have to come in cold, look at this group of 100 polygons and start drawing circles. They come in and say like, hey, the precipitation pattern today, that's going to really be driving the avalanche forecast. Maybe I should start with that map, or the wind speed, or the distribution in temperatures across the state. So how do we do that? Well, we're already doing numerical modeling for the weather. So these are spatial distributions that maybe we can suck in to those forecasting tools to give the forecasters a start. It's not to say that they have to stick with that distribution, but if they say, hey, this snowfall on the left there is really the closest to what I think the pattern is today, they can start there and start moving stuff around. Or on the right there, we have essentially our way of looking at rain on snow events. So the zero wet bulb isotherm. Say that 6 times fast. And so again, like, not to say that they have to use that pattern, but if that gets them close enough, they can start there and work more efficiently. Some other examples with wind speed, both just modeled wind speed or wind gusts. So you can see how those might fit together. Another thing that we're doing is looking at simulating the snowpack model that Sam was talking about. So we're driving the snowpack model with our weather model. So every grid cell, it's a 2 kilometer grid, every grid cell above 2,800 meters. In this particular case, we're running the snowpack model. And if we look at one of those polygons, so this is polygon 34 over Summit County, and each one of those red dots is where we're simulating the snowpack. And our hope is that, because we can get a lot of different things out of those snow models. We can't really get whether avalanches are going to release or not, but we can get weak layers, thickness of slab, characteristics of the slab, hardness. We can get water into the snowpack. And so if we use that, some folks in Canada working with Pascal Hagley, Florian, and Simon Horton have developed a tool where we can take all of these different simulated snow profiles and concatenate them into a typical snow profile for a specific area. So in this particular case, we have where all the snow profiles are on the left. In the middle there, we have the hardness profile from all of those snow profiles lined up from hard to soft. And then on the far right, we have what the typical snow profile, hardness profile looks like throughout that area. And so by using techniques like this, we can't do this right now, but we can start to group common areas and again, give the forecasters different tools for how to figure out that distribution. Oh, all kinds of animations. So our hope is that this will help the forecasters kind of group these different areas together, and that maybe eventually we can go from 100 polygons to something like we're doing with the weather. This is our 4 kilometer grid for the weather model. And so if we can start to populate these different grid spaces with common snowpack characteristics, then the forecasters can go in and decide how they want to nudge things to get the distribution they want for the day. So this will be about 9,000 forecasts.
Right, and you need a forecaster for every 4 kilometer grid, don't you? forecaster.
We don't need it for the weather, so I don't think we need it for the avalanches either. So this will obviously make writing products really difficult. So who knows how we're going to figure that one out, but one way is OpenAI. Here's the avalanche forecast that we wrote for one area a couple days ago, and you can see at the top there what I typed in to generate the forecast down there in the bottom piece. So maybe someday we can get to the point where we tell the computer what the danger is and what the problem elements are, and it can give us a rough draft of the forecast. And instead of writing 10, we can write 10,000. I'll just leave that up there if anyone wants to read it. So that's the end of my talk. Thanks for your attention. I hope you asked Sam all of the hard questions. So, yeah.
I'm just kind of curious with the feedback from the user base. I can see that some of these changes being potentially a lot to digest.
Yeah. It's a really good question. And so, I mean, I can tell you what we've gotten, but also just with the caveat that what we receive is only one look at what the user base thinks. And we're actually doing some work with folks in Canada at Simon Fraser University to try to get a more objective view of what the users think, and even more than what they think, what they get out of the forecasts and how we might get them to get what we want more. So really the feedback has been overwhelmingly positive. But again, it's hard to put too much stock in that. We did make another change in the program that I didn't talk about this year, which was we stopped emailing the forecast to people. And that was really because it's really easy to maintain 10 email lists. You can sign up for one, and we can send emails to the Vail Summit County Zone all day. But now we're generating forecasts by lat lawn. And so keeping email lists for all of the lat lawns in Colorado was more than we felt like we could do. So most of the complaints that we got this year were that people didn't get their emails, like overwhelmingly. So it masked that a little bit. Does that answer your question?
Yeah. That the Swatch example, like I thought about that every time we're doing this, and like Monarch Pass is like the perfect place for this.
Yeah.
So that's very cool. I guess I was wondering, if like 15% of the time updating in the morning, it's like once a week or something.
Yep.
In that ballpark. And
Yep.
do you have a system? I mean, you're not emailing people. Like in terms of, do people have to just check in the morning, or do you have some way to let people know in the app or something that a forecast has been updated, so they don't have to check it afternoon?
Yeah, no, it's a really good question. We've been trying to train people really for a while, but more recently to check the forecast. Like don't work on our schedule, work on your schedule. And so check the forecast when you want to and when you need the information, and we will make sure that you have the best forecast possible. So that's one of the things that we've tried to push. What we are using is social media to tell people when the forecast is updated. So we send out a round of Twitter messages. I think we did the same thing when you worked there. And so if we do an update like in the morning or midday, which we will do occasionally, we send out a host of messages telling people about it. Yeah. Yes?
So if you're telling people that they should look in the morning,
We're telling them that they should look when they need the information.
Okay, but you've changed it so that you want them to look in the morning because you want to capture that. Why do it in the afternoon?
Well, we're not trying to get them to look in the morning. We're trying to get them to digest the information by not looking at our paradigm for space. So don't think about the Vail Summit Zone. Think about skiing on Vail Pass, and click on Vail Pass so that how you digest the information is different than how we create it. And don't look at the forecast when you think we're going to update it. Look at it when you need the information. Okay. And it'll always be the best that we have when you look.
Well, that of course, yes.
Well, before we could sit on something, right? Like we would know that the danger was high on Monarch Pass and low on Sargent's Mesa, but we didn't tell people.
But conversely, like I agree with that. Like you know, when we get information, and that's where social media really comes in, is we can really get the word out really quickly. You know, to people when it's like, hey, everyone needs to know this.
Yep.
You know, we can put it out in the afternoon or whatever. But I just know from forecasting, there's many times where, you know, you're going to bed with one idea in your head as to what the danger is going to be. And then in the morning, it all changes because sometimes it's the weather. Usually, I think it's an observation comes in, and you know, we get a photo, we hear a story, we get an email that kind of changes everything, and because it only takes one, you know, to really, I mean, it can.
It can.
It can.
Sometimes one is an anomaly.
Sometimes it is, but I mean, and that's our job, right? Is to know if it's an anomaly, or you know, or is it the start of a pattern, or is it part of a pattern? So how do you, like, as a forecast, I'm like, oh my God, like, thank God that guy wrote in or that guy wrote in. I'm putting it in the advisory. It's changing. I'm changing how I'm telling this story. How do you account for that?
Well, it sort of depends on the situation, and your point's a really good one in terms of we get information through a lot of different time cycles, and depending on what the information is and what the situation is, we may want to do different things with it. So if we really felt like the forecast that we issued in the afternoon needed to be updated, and this has taken us a little bit of time, but essentially where we are now is the tier 1 danger rating is like, we will make changes to the forecast if the tier 1 danger is going to change, and that's essentially the color on the map. So if we feel like that needs to happen, then we'll do it, and we have it out by, you know, about 5 a.m, really. If we have information that we think the public needs, but is not going to change the product dramatically, like the tier 1 rating. So if we feel like, again, like, so we do problems by the elevation and aspect rows, right? So if we have one segment of that 24 blocks that's going to go from white to gray, we'll wait and do that in the afternoon, most of the time, unless we feel like it's the most important octant. If we feel like there's an observation that comes in, we'll put it out through social media, and we'll alert people, because we're putting that out every morning anyways. What you're describing, you described it perfectly for the most complicated scenario for how we're doing it, but I'm sure that you have the same issue where something comes in at 11:30. And so do you reissue all your products at 11:30, or do you wait?
In the morning.
Well, if you've issued your product at 7 o'clock in the morning,
Yeah.
and something comes in at 9 or 10 or 11,
Rare.
but we get that information, sometimes from ski areas, sometimes from, you know, people who send us information on social media that didn't want to do it at night. So we get information 24 hours a day. And so the problem that you're describing, although very real, it doesn't change that much based on your forecast period.
Because your obs coming in, I mean, the most valuable obs are the most recent obs, and you know, most of our obs coming in for here, and I'm assuming it's everywhere. People go out skiing, they go out climbing, and that evening when they're home is when they submit their observation. Not always, some wait till the morning, some, you know, but the bulk of them are coming in, and certainly some of the more important ones are coming in because people are kind of freaked, you know, writing us, and
yes, but not always. Like, we get a huge push of observations Monday morning at 9 o'clock when people get to work.
That's awesome.
So like on a busy weekend, like we will get like a huge amount of information on Sunday, but we will get another push on Monday. Again, I think like your point is really good and completely valid, but I think how you lay your forecast cycle onto the 24 or 48 hour calendar has pros and cons no matter what you do. Like for many, many years, and I talked about this a little bit, we wrote forecasts the whole 10 zones in the morning and in the afternoon. So I would come in, I worked the forecast desk at that point. So come in at 4 o'clock in the morning, go through the whole process, write all 10 products, have them out by 7 o'clock. Then I would sit around and call the other forecasters, field phone calls from the public, get a bunch of information, redo everything at 3 o'clock in the afternoon and have it out by 4. When we decided to get rid of one of those cycles, we were like, we can't maintain doing this with our staff at that point. And so we polled the public. The public at that point wanted everything in the morning. The forecasters 100% felt their afternoon products were higher quality. So it's just a matter of balancing pros and cons.
I think we've got it. One more.
Yeah. You kind of alluded to it in terms of volume of observations, and I'm curious, what's the density of data that you're getting? How many of your 103 forecast zones have a weather station? How many are you getting consistent observations from, and how is that influencing how good your data is as far as divvying up and then B, the decision on whether to make things one polygon or split it into two?
Yeah, no, it's a really good question, and it changes quite a bit from place to place. So, there's definitely areas there that don't have any weather stations, but that was true with our 10 zones as well. The data density for on the snow observations changes dramatically, and we have a visualization for avalanche occurrence that the public can use, and if you go look at that for any period of time, you'll see these stripes of reported avalanches, because where people are is where we know about avalanches. We do have the ability to write very coarse forecasts, and so in the spring, we forecast through Memorial Day on a daily basis, and the number of areas that we're issuing forecasts for is likely to decrease as we move into there, as we just start to broad brush things. There's nothing in the system that prevents us from issuing one forecast for the state of Colorado, but we can also issue 103. So that flexibility gives us the ability to describe things at the level of detail that we know them. Does that make sense? He's cutting me off.